Assalamu alaikum dear students. Today we are going to solve the examples of this exercise. The first one is a line perpendicular to the line segment joining the points 1 and 0, 2 and 3 divides it in ratio 1 is to n. We have to find the equation of this perpendicular. This means that a perpendicular is drawn to the line segment with endpoints 1, 0 and 2, 3. But this perpendicular joins this intersects it in ratio 1 is to n. Then we have to find its equation. Let L is the perpendicular. So this means that this is the here perpendicular. This line, it is perpendicular L, and it is perpendicular to a line segment 1, 0 and 2, 3. 2, 3. Let A be the point where it intersects this line. That is here. This is the point. Now it divides this line segment 1, 0 and 2, 3 in ratio 1 is to n, which implies that its coordinates by section formula is 2 plus n upon n plus 1. 3 divided by n plus 1 by section formula. So this means that now slope of this line segment 1, 0 and 2, 3 is given by 2-point form, that's m dash equals to 3 minus 0 upon 2 minus 1, that is 3. So this means that this m dash is the slope of this line which passes through point 1, 0 and 2, 3. Now L is the perpendicular to this line, which implies that by condition of perpendicularity, slope of this L, which is m, is given by minus 1 upon m dash. So it is simply minus 1 upon 3 because by condition of perpendicularly. Also it passes through this point, that is this point A, whose coordinates by section formula are given by 2 plus n upon 1 plus n and 3 divided by 1 plus n. Now we have a point through which a line means perpendicular passes, that is point this A, and we have slope. Its slope is given, that is minus 1 upon 3. So by slope point form, which is y minus y naught equals to m times x minus x naught. So when we substituting y naught equals to 3 upon 1 plus n, x naught equals to 2 plus n upon 1 plus n, m equals to minus 1 upon 3, we simply get by simplification it is x plus 3y equals to 29 plus n upon 3 into 1 plus n. So this is the required equation or the required form of this perpendicular, which is drawn to the line segment 1, 0 and 2, 3, and it intersects or it divides this line into ratio 1 is to n. So this is the required equation of this perpendicular. Now second one is we have to find the equation of line which passes through point 2, 3. Passes means here this point lies on this line and cuts off equal intercepts on axes. So we will use here the intercept form, and intercept form is x upon a plus y upon b equals to 1. Name it equation first, where a is the intercept on x-axis, b is the intercept on y-axis. Now by question, the line passes through 2, 3 and it cuts off equal intercepts on axes, which implies that intercepts are equal, means a equals to b. Also it passes through point 2, 3, means this point lies on this line. So this means that this a equals to b and 2 equals to 3 should satisfy equation first. When it satisfies, we simply get a equals to 5, which implies that b equals to 5. Hence by substituting in equation first, we simply get x upon 5 plus y upon 5, which is 1, or x plus 5 equals to 1. So it is the required equation of a line which passes through point 2, 3 and cuts off equal intercepts on axes. Now another problem is find the equation of line which passes through point 2, 2 and cuts off intercepts whose sum is 9. So here again we will use the intercept form, which is x upon a plus y upon b is 1, but here the sum of the intercepts is 9, which implies that intercept is a, intercept is b, their sum is 9, or simply a equals to 9 minus b. It passes through point 2, 3, which implies that these two equations, that's a equals to 9b, x equals to 2, y equals to 2, should satisfy first. So when we substitute here, we simply get the equation which is quadratic in b, hence b equals to 3 or b equals to 6. So when b is 6, a is, when b is 3, a is 6, or when b is this 6, a is 3. When we substitute a equals to 6, b equals to 3, we get one form, that is x plus 2y equals to 6, or when a is 3, b is 6, we simply get 2x plus y equals to 6. Now last example. A perpendicular is drawn from origin. Origin means whose coordinates are 0.00 or where the two axes intersects the line at point -29. Find the equation of this line. Now here perpendicular passes through point 0, and this -2 and 9, which implies that the slope of this perpendicular is -9 upon 2, because its endpoints are 0, and -2, 9. Now we have to find the equation of this line to which we draw a perpendicular from origin. Now the slope of this line is given by -1 upon the slope of perpendicular, because by the condition of perpendicularity, which is simply 2 upon 9. This means that also this required line passes through point -2, 9. So by slope point form, m equals to 2 by 9, x naught equals to -2, y naught equals to 9. By substituting, we simply get 9y minus 2x equals to 85, which is the required equation of the line to which a perpendicular is drawn from origin, and that perpendicular intersects this line at point -2 and 9. So again here we used this slope point form. Inshallah, in tomorrow's video lecture we will start a new form of the straight line, which is called as the general form of straight line. So thank you.